called Fundamental Theorem of Calculus. So what is this theorem says? Mathematically, the definite integral is often computed using an antiderivatives of the function. Okay, so fundamental theorem of the calculus states that if f of x is an antiderivative of the f of x, then integral of a to b f of x dx can be written as f of x with the limit a to b, so which is nothing but f of b minus f of e. So usually we put a modulus if we are talking about area, or else we can keep the sign whatever we get. So but area is always positive, and the negative area also has a significance that depends upon the question. Let me not comment much about it right now. So let us just understand the theorem as it is. Okay, so area function associated with the definite integral represents the net signed by area between net signed area between the graph of a function and the x-axis over the specified interval. The function is like this, and there's a x-axis, and we have a limit now a and b. So this is the area we are talking about. So this area of the given function between a and b with the x-axis, and y is equal to a, y is equal to b between the curve. So this is the region we are talking about. So that is what is expressed here. If there is a function like this, and we have a and b here. Okay, so we have x is equal to y is this is x is equal to a. Sorry for that. This is x is equal to a. This is x is equal to b. Right. So between this, we are getting the area. Okay. So area function is typically treated as a of x, which is always given by integral only a to x f of x dx. Okay, so this is again symbolical way. So we just have to remember the theorem. We can use them in the application of integrals mainly. Okay, so let me erase this part again. So we have now under definite integrals again, we have second theorem. What does it say? Yes. So the theorem says, let f be a continuous function on the closed interval a to b. What is in the closed interval? We are having a and b included in that. Let a of x be the area. Then a of x is equal to a dash of x is equal to f of x to all x that belongs to this region. So this is the theorem. Okay. So just remember this theorem statement. Okay. So let's quickly check the next theorem. Second fundamental theorem of calculus. Okay, if there is a statement asked, we should be able to know that, and the application we're going to see later. And the theorem says now, if we have an integral of f of x dx from a to b, its value is going to be f of x from b to a, and that is by substituting the value of b minus a. What we get, that is our area. So let f be a continuous functions defined in the closed interval a comma b, and f be antiderivative of f. Then we are having this. So just like the examples I gave, if we know the value, we can substitute and get the value of that as it is. Okay.